Good day. This is Varun Nagaraj, CEO of Sierra Monitor, and welcome to episode 2 of the video series we're putting together in partnership with Control Trends. You know, one of the advantages of having a 12-year-old son is that you get to relive your own misspent youth once again. So we were watching this movie Wayne's World a weekend ago, and he really caught on to the tagline, if you will, Wayne's World, party time, excellent. And then I told him I was actually doing a video for my colleagues at Control Trends, so he wanted to know if it was going to be as good as Wayne's World. I said probably not, but I certainly promised to say excellent before we'd get started. So welcome to Control World, if you will. So last episode, we talked about the industrial Internet of Things. We talked about how it represented a great opportunity, a once-in-a-lifetime opportunity really for OEMs, for system integrators, and for facility managers, and for people like us who get a chance to provide core technology into this space. After discussing the possible impact of the industrial Internet of Things, or the IIoT, we spent time talking about some of the key business model challenges that we expect to see out there. Who benefits, who pays, how does the value get divided between the various players, and so on. And we finally talked about a new technology architecture that had been proposed by the Industrial Internet Consortium, an IIoT reference architecture for thinking about how the pieces all could work together. In today's episode, we'll carry the same theme. We'll look at sort of a trend, and we'll really share some lessons we've learned from the field about business models, and hand in hand will be the technology infrastructure that's required to realize those IIoT business models. Now, before we go there, if you're like me, you're surrounded by the press, and you're reading these, really interesting stories about the Internet of Things. You're reading use cases, how people are benefiting, what kinds of cool things vendors are doing. And after a while, at least for me, it begins to blur a little bit. Everybody seems to be talking about the cloud. Everyone's talking about data analytics. And at some point, you start saying, what was the difference really between use case A and use case B? Or is it really just something that everybody does and therefore something I need to do? So I find it helpful to think about these stories or these use cases in concrete buckets, or in different categories, if you will. And so I'd like to share with you today a framework we use within our company. And this is a framework we actually use in our work with various OEMs who are our customers. So this is what I'm sitting down with the OEMs with and talking to them about how they look at their business and how they see the IIoT impacting them. So I think it's a really interesting framework. So please give me the chance to talk to you about this. And I'm pretty sure that you're going to find this particular way of looking at IIoT use cases to be useful in your own practice. Now, I'll try and make a distinction between what I'm proposing to OEMs, so folks that make boilers and chillers and air handlers and sub-meters and so on, and facility managers who actually use all of these pieces of equipment. But for a large part, what I'm talking about is really directed towards the OEMs in terms of why make your product a smart connected product, as Professor Michael Porter of Harvard would call it. What is the value in turning your product into a smart connected product? And as you can see in this diagram, which is kind of the stairway to heaven, if you will, there are 4 steps here. And these are the 4 categories of benefits, but they're also drawn up as steps. And the reason they're drawn up as steps is because we believe that a company needs to ideally realize the benefits on step 1, which is the lowest step, before moving on to step 2 and then subsequently to step 3. And so they are categories, but they do build on top of each other. So let's take a look at the lowest step, if you will. And by the way, it is still a step, right? So it still requires you to make an effort to step onto this step 1. And step 1 is really about remote support and remote service. So in this particular case, imagine you're an OEM. Let's say you're building sub-meters, or let's say you're building chillers. And you look at it and say, I sell my sub-meters and chillers through channels. They go out, they get installed. Perhaps I'm part of the installation, perhaps I'm not. Perhaps I know where they are, perhaps I don't. I just happen to know the territory that they shipped into because the dealer or the distributor took it from there. And the data that my beautifully engineered submeters and chillers produce gets collected and gets funneled into the building management system that might exist, or perhaps it's a SCADA system if it's a semi-industrial setup. And so I really don't know how my products are doing. I mean, I hear about them from time to time when they come back because of failure or because the irate customer calls. But by and large, I am not operationally involved in the data that my products are producing because they're essentially being fed into the BMS system. Now, the vendor that put the BMS together certainly is aware of the overall health of the facility, and yes, in my own small way, my products are contributing to the health of that particular facility. But I personally do not have touch with my products. Now, this might be a satisfactory state of affairs for you as the OEM. Perhaps that is the strategy. But we've had quite a few conversations with OEMs who are dissatisfied with this particular status quo because it has essentially turned their products into just commodities that are providing data with all the value really being captured at the management system level. And so we've talked about the notion of a path B, if you will. So what is a path B? A path B is the ability for a product like a submeter, a chiller, a boiler, and so forth, not only to feed data into the building management system, but to also really connect in to the cloud. Well, whose cloud? In this case, it would be the OEM's own cloud. So it would really be the notion, if you will, of a submeter or a boiler or a chiller or an air handler, or pick the instrument or the system of your choice, as in the days of ET, calling home, right? These would be devices that are connecting back into the network operations center of the OEM, registering themselves and being available for remote touch and remote access. Now, who really benefits from this? The OEM certainly benefits because suddenly they have regained touch, they have regained control and visibility into their most precious assets, their products that they have sold to customers. And with that data, they can do a bunch of things, and that's how the step 1, step 2, and 3 are organized. So in step 1, what is it that the OEM could do? With now availability to the assets that are out in the field, the OEM can really provide superior service and support. And this may provide the OEM an opportunity to really differentiate themselves from the competition. Now, how might they provide that superior service and support? It probably is going to come from the fact that the OEM is going to have continuous visibility into what is going on site. So by connecting in to their specific device, through the gateway that obviously got them into the cloud, by connecting to their specific gateway and to the specific device, they are going to know exactly what the health of that system is. They're going to know what the operational parameters are. They're going to have a full visibility into the alarms or troubles and alerts that are being generated. They may have the ability to reset it. They'd have the ability to do remote firmware upgrades on their product. They really have the ability to make their products work better. So when that call comes in from the customer that something isn't working, the OEM is going to just take a few minutes to really dive right into the product and see what the issues are. Or better yet, in fact, the OEM in their network operations center might be alerted to an issue well before the customer is alerted to an issue, and may in fact initiate proactively the conversation with the customer. Now, the smart OEM could also actually offer this up as an extension to their customer. So their customer, who otherwise might have thought of the submeter or chiller as nothing more than an element inside their building management system, may now have the ability to directly reach these particular products remotely. Now, of course, they can always connect to their BMS system and take a look at everything they want, but there are many, many facility managers or specialists who are interested in specific devices that they're responsible for. And this gives them a chance to remotely access it. And of course, they would be accessing it through the OEM's service, right? So it's a value add from the OEM to that particular facility manager, the ability for them to access these devices remotely. So that alone, step 1 alone, is, I believe, enough reason to embrace the industrial Internet of Things and to embrace the notion of remote connectivity and to really challenge yourself as to what your business model is. So let's move on to step 2. Now with step 2, you're actually starting to get a little fancier, right? So step 1 was all about just having visibility to your assets and being able to reach down remotely and in a secure fashion to those assets. Now in step 2, you begin to recognize the temporal value of data. Now sounds like a fancy phrase, but what it means is data, when you have a lot of it stored with a time context or a timestamp, is useful for multiple things. You can tell a history of what happened, And based on the history of what happened, you can potentially assess what might happen in the future. You might be able to pick up on certain trends that just taking a look at an instantaneous snapshot may not be good enough. And so those kinds of capabilities, the ability to actually store data and analyze data, then leads to many of the benefits that are captured on step 2. So if you take a look at the slide, you're going to basically look at it and say step 2 allows efficiencies to be gained, right? So these are not just about better service and support. This is about having more efficient operations through analysis. Well, whose operations? And again, it's always good to ask who benefits. And here, the benefits actually can be equally split between the OEM and the OEM's customers, which means that in the right use cases, I believe the OEMs will have the ability to charge for these kinds of value-added services that their customers also are benefiting from. So from a customer perspective, there are emerging use cases about how data can be used to improve a customer's operation. And I have a couple of examples there, and some of the ones that I like are GE and the jet engines that they use. GE's jet engines produce a phenomenal amount of data. The number of sensors and instrumentation in that is truly mind-blowing. Now, GE's customers are either companies that make airplanes, or in many cases, GE has direct contracts with airlines, and they are responsible for the maintenance of those particular engines on behalf of those airlines, like United Airlines, American Airlines, and so forth. So in this particular case, GE is able to help improve the United Airlines efficiency by pointing out that when flights go from Honolulu to San Francisco, certain flight patterns tend to use far less energy or far less fuel than other flight patterns. And they're able to correlate that back, not just to dumb luck, but to specific sensor data that the engine information might have been, that the engine sensors might have been gathering. So this kind of insight from GE back to United Airlines can save United Airlines a whole bunch of money. So this is an efficiency gain that United Airlines is getting by virtue of the analysis that GE is able to do on behalf of United Airlines. Right? This is an example of an efficiency through analysis. And in a situation like this, GE is perfectly justified in essentially looking at the cost savings that they're providing United and making sure that they are adequately compensated for the benefits that they're bringing to United Airlines. Right? So this is one where there is a revenue model for GE, which is the OEM, which is basically also benefiting GE's customer, which in this case is United Airlines. Or if you're a company that makes a fan, and my favorite every year from the AHR show are big-ass fans. So if you are basically a maker of fans, and industrial fans and large air-moving kinds of fans, you could look at your scope and say, my only job is to make sure I feed the Johnson Controls BMS with whatever data they want. I mean, I'm just a fan company after all. But that's not the way Big Ass looks at their business, right? They look at their business as saying, how can we increase the efficiency of airflow inside of our company? What is it we can do based on sensor information that we have about occupancy, or even about personal people preferences, or based on what the outside weather is doing? And how can the Big Ass system be a self-regulating system that can essentially deliver efficiency and energy efficiency to its customers? In a situation like this, you can imagine the value that the network operations center of a fan company like this could have by having direct reach to their fans. The things they could learn about the environments that they work in and the algorithms they could implement to actually improve their customers' efficiencies. These would not be realizable if the only approach that the fan company took was to say, I just create data points that go into a BMS. And this is the reason why OEMs should think more expansively than just being subservient to the BMS system, because it allows them to add value for their customers. Now, this kind of data analysis also adds value for the OEMs themselves. For example, if an OEM is in constant touch with their customers and they have the ability to store data and analyze data, they might be able to predict and find those customers that actually are high utilization customers that perhaps represent opportunities for the OEM to sell more product to. So therefore, this industrial Internet of Things connectedness really becomes a sales generation or a lead generation tool, because you're able to profile your customers' use. You may be able to offer predictive maintenance, right, which basically reduces the OEM's cost. So rather than having a scheduled maintenance cycle, the OEM moves to a predictive maintenance cycle, which essentially reduces the cost or increases the efficiency for the OEM. Similarly, by watching the product in action, product quality could be improved. So there are many things that the OEM can do to take advantage of this data being stored in order to improve their own efficiency. Now, I do want to highlight the difference, the technology or the architectural difference between step 1 and step 2, and then I think we will actually call it a day for this particular episode and pick up on step 3 and step 4 in our next video cast. So let's take a look at the technology differences. In the case of step 1, what we're really talking about is making sure that OEM devices, and by the way, anything I'm suggesting for OEMs, integrators can do on behalf of OEMs in an aftermarket setting as well, right? So if you're an integrator, the fact that I've been focusing on the OEMs, I hope you've simply been saying, okay, and if an OEM doesn't do it, I as the integrator can certainly do the same service as an aftermarket service. So from a technology perspective, coming back to what the OEM can do, the OEMs can certainly take a gateway, like the field server protocol gateway, and use that to implement path A, which is to connect their devices into the building management system. But that exact same field server protocol gateway can be used to also enable path B, which is creating a registration and a phone home service for their set of products back into a cloud-based network operations center. So that would be one way in which, from a technology perspective, an OEM could get going. Now, the data is still stored on the field server protocol gateway. We're not talking about moving data and storing data in the cloud, but what we're talking about is a cloud-based service as being a secure way of connecting in to the field server protocol gateway. Now, in step 2 is predicated on the availability of large amounts of historic data. And the cloud is a wonderful place, by the way, to store large amounts of historic data. So step 2 differs from step 1 at a technical level because step 2 involves data warehousing, data mining, data intelligence, and the infamous analytics word, which basically means what you do in step 1 plugged in with an analytics cloud engine is the way you would actually do step 2, because the analytics cloud engine that you're plugging into your step 1 infrastructure is how you would end up storing the data, mining the data, and finding these nuggets of insight into the data. So step 1 and step 2 do involve slightly different technical infrastructures, but the technical infrastructure for step 2 also builds on the technical infrastructure of step 1, just as the business benefits of step 2 build on the business benefits of step 1. Now, step 3 and step 4 begin to get more fanciful. Step 3 and step 4 begin to talk about how OEMs can not only just get more efficient, they can get creative, they can get innovative, which means they can do things that haven't been done before. So we will think, and this is a topic worthy of discussion by itself, and in order to pick this up and give it its due justice, we will basically have a separate video cast episode on steps 3 and steps 4, which are really about innovation and total enterprise optimization. So until then, happy control networking to you, and we will see you on episode 3 shortly. Thank you.